Okay. So, with that numerical only, right, later we have come back again. So, Z is equal to, you know, this is a series RLC circuit, it is R plus J L omega minus 1 upon omega C. Omega I told you it is 40 because sin omega t, so omega is 40. So, L omega, L is given 0.2 Henry, so L omega minus 1 upon omega C, omega is 40 and C is given 0.0014 farad. So, it is actually becoming 10 minus J 10 ohm. So, 14.14 angle minus 40 degree because it is 10 minus J 10. So, your what you call it is root over 10 square plus 10 square the magnitude, and that is equal to 10 root 2. So, 10 root 2 will be 14.14 and angle will be tan inverse your what you call minus 10 by 10 because it is 10 minus J 10. So, it is tan inverse your minus 1, that is minus 45 degree, that is why this angle is minus 45 degree, right. So, let me clear it. So, this is my impedance Z, right, this is my Z. Now, therefore, IT is equal to, it is, look, first as it has mentioned in terms of time. So, we have to use the sin omega t. So, IT is equal to your, this is 100 sin 40 t. So, 100 sin 40 t divided by this Z 14.14 angle minus 45 degree, voltage by current, voltage by impedance, right. So, it is becoming 7.1. if you divide 100 by your what you call, actually this will become approximately 7.07 because it is 100 divided by 10 root 2. So, it is becoming 10 by root 2, that is 10 into 0.707 because 1 upon root 2, that is actually 7.07. So, it is 7.07, I have approximated as 7.1, right, and this angle is your what you call, this angle is your angle minus 45 degree. So, basically it is sin 40 t plus 45 degree, how we made it, right. So, let me clear it. So, whenever you make your phasor quantity, for example, this is my your what you call my voltage, this is a maximum voltage, right. If you take the RMS value, so it will be 100 by root 2, right, 100 by root 2, that is it is 50 root 2 volt, right, and impedance is 10 root 2, actually I told you 10 minus J 10 is 10 root 2. Therefore, my current will be your what you call 50 root 2 by 10 root 2 is equal to 5 ampere. This is my RMS value of the current, right. If this is my RMS value, if you multiply by root 2, it will be 7.07, right. Now, let me clear it. That means, and that means this one, this I mean when you write in the phasor term, right. So, I actually will be I will be equal to, it is 50 root 2, it is sin 40 t. So, sin omega t plus theta, no theta is here 0. So, it will be 50 root 2 angle 0 degree, and this one 14.14 we can write 10 root 2 angle minus 45 degree. That means, this one actually root 2 will be cancelled, it will be 5 angle 45 degree because angle 0 degree by angle minus 45 degree, it will go up plus sign. So, it will be 0 degree plus 45 degree angle is equal to angle 45 degree, right. So, that is why this current will be actually RMS value, it actually 5 angle 45 degree. Now, that let me clear it. So, current I is equal to 5 angle 45 degree, right. Now, its peak value will be 5 into root 2, that is 7.07, this is the peak value, and if you want to put it in your what you call in the t term, so it is angle 45 degree means it will be sin omega t and plus 45 degree, right. So, 7.07, I have approximated this one as 7.1, this value is equal to 7.07, right. So, but approximated as 7.1, right. So, that is why we are what you call, we are making it, it is 7.07 sin 40 t plus 45 degree, this way it has been made. Hope you have understood this one, right. When you will go through this video, please see that if you have any question, anything, you put the question in the forum, we will answer all your questions, right. So, if you have anything, but I told you just see how things are, right. The next is your just hold on. So, next is that your VRT and your what you call and VLT and VCT. So, VRT is IT into R. So, it is your that means R is equal to 10 ohm. So, it was 7.1 I took. So, it is 71 sin 40t plot. Actually, it should have been 7 point your what you call your 70.7 because 7.07. So, approximated as 71, right. So, there should not be any confusion. Now, similarly, your VL is equal to IT into JXL, right. Now, IT is equal to your what you call we have our IT is equal to 7.1, we have taken approximate value, then sin, then 40t plus 45 degree, right. Now what you are doing is if you just and multiply it by JXL, XL is equal to 1 upon L omega you calculate. My question is that J means angle 90 degree, it is angle 90 degree. So, that is plus angle. So, with 90 degree and 45 degree if you add, it will be 56.8 actually 40t plus 135 degree, right. So, same way the way I showed you, if you take RMS value phasor and if you just multiply this one. So, this is J means it is angle 90 degree plus 90 degree, that is why it is sin 40t plus your 135 degree. Similarly, VCT is equal to IT into minus JXC. So, minus J means it is angle minus 90 degree, that means and multiplied by IT. So, here it is 45 degree. So, 45 minus 90 that is why it is minus 45 degree, right, that is my VCT. So, all these things this is your plus just let me clear it, this is your plus minus instantaneous polarity, this voltage is V, right. So, all these things are shown here, it is 10 ohm, it is J 8 ohm and it is your minus your J XC. So, minus J 8 ohm and it is 50 volt, it is 40 volt and it is your what you call 90 volt. These all are actually your RMS value because V is equal to given 100 your 100 sin 40t, this is given, right. So, 100 by root 2 is equal to 70.7, approximately it is 71 volt. So, this is RMS value and if you when you are calculating VRT, this is the peak value, Vm is equal to your 71, approximately it is 70.7. So, if you take the RMS value 70.7 by root 2, it will be your what you call 50 volt, that is why this one is 50 volt, right. Similarly, for VLT this is 56 point, let me clear it. So, VLT is equal to 56.8, this is the maximum value. So, 56 by 8 by root 2, that will become your 40 volt, that is why this is 40 volt, this is RMS value. Similarly, for this capacitor, it is a voltage across this VC, it is the peak value 127.8 divided by root 2, that is actually 90 volt, right. And this V I told you, this is 71 means 70.7 volt, right, and this is the current I told you I is equal to RMS value of the current is 5 ampere because it is 7.1. So, that is actually 7.1 means it is approximate value 7. It is the maximum value. If you divide by root 2, it is 5 ampere. So, that is why this is 5 ampere. This diagram is completely based on this RMS value. So, let me clear it. So, all these things are RMS value, these are all RMS value and this is that your what you call circuit. This example, this kind of example I have taken, simultaneously I can show you the peak value and RMS value, peak value of the RMS value such that our understanding will be very much clear, right. So, now question is in terms of phasor. Now, I have already told you in terms of phasor it will be just Z bar you make or simply this thing, right, complex quantity. So, it is 100 by root 2 angle 0 degree because it is 100 sin 40t the voltage. So, that is sin omega t plus 0 degree. So, it is 0 and divided by this Z. So, this is the current 5 angle 45 degree and this is VR Ri is equal to this you are what to call 50 angle 45 degree. These are all magnitude 50 volt 40 volt this thing. Now, it is Ri. So, his angle is 45 degree. Now, VL is J into XL. So, your J in XL into I is equal to 545 degree angle 45 degree and JXL means it is angle 90 degree. So, 90 plus 45, so 135 degree and multiply by XL is computed here, it is A or what you call your JXL into I. So, whatever value comes, it is your 8 ohm it is given. So, it is 40 volt, right, this is all volt, right. 40 volt. Similarly, Vc is equal to minus Jx into I, because of minus, the angle minus 90 degree. So, minus 90 degree and it is 45 degree plus, so it is minus 45 degree volt, right. So, this is your what you call, this is your Vr, this is your VL, and this is your Vc. So, this already I have explained you that how one should take. So, that is why this example is taken such that maximum value and RMS value, all the concept, our concept will be cleared, right. Next is, now question is that note that in terms of phasor quantities are all RMS values, right. So, whereas as time function or as instantaneous values are expressed with maximum values. When you are putting in time function, it should be maximum values, and when you are putting in the phasor form or quantities, it will be in RMS values, right. That is this note is written here, that is the note is written here. Now, in the circuit, power loss is simply I square R. So, basically it will be 250 watt, that is your I square loss. Same way you can do is that power factor, the what you call, another thing is that you can make it you just calculate it, that Vi cos theta also will give you the same value, right. So, if you I mean if you find out that your what you call this power loss dissipated in the resistor R is I square R, I is the 5 ampere is the RMS value into 10, R is the 10, 250 watt, use the relationship Vi cos theta, and you will, and cos theta power factor later we will see there it is leading power factor. So, that is your 0.707. So, actually if you calculate Vi cos theta, you will get the same value 250 watt, right. So, that means if we draw the phasor diagram, this is your reference you take, that is your supply voltage, it is 70.7, so approximately 70, this is the supply voltage. Now, if you come to Vr is equal to, actually it was given Vr, it was given 50 angle 45 degree, that is with respect to this one. So, this is my Vr. Similarly, I also is this one is equal to 5 angle 45 degree, and Vr is equal to, R has no angle, it is simply multiplied by the 10. So, same along the same line, this I is plotted and this Vr is plotted, because your Vr is equal to 50 angle 45 degree and I is equal to your 5 angle 45 degree. So, this is the with respect to, this is your reference, the supply voltage, that is your 70.07, that is approximately 71 volt. Next is your VL. VL is equal to your 40 angle 135 degree, that we have seen. So, this is this angle, this total angle is 135 degree with respect to the reference V supply. That is why this is your VL, this is your VL. Similarly, Vc is actually is equal to 90 angle minus 45 degree, we have seen, right. If you come to this, that we have seen all, right. This all Vr, Vc, VL all are there, right. So, in this case your this is Vc is 9, this angle is 45 degree, right. So, if you look into that current I actually leading the voltage by 45 degree, right. That means power factor is leading, current here is leading, because angle is positive, right. So, current is leading and this is 45 degree and this is VL and this is Vc, angle between this your VL and Vc just opposite. So, it is 180 degree if you make it, right. So, resultant actually your what you call the current is leading. So, Vc minus VL will be your what you call, in that case as current is leading. So, Vc will be greater than VL. Look at that, Vc is 90 volt and Vc is 40 volt. So, Vc is greater than VL, that is why current is leading, right. So, you have to understand each and everything, right. That is why this current is 45 degree. So, you know the your what you call, this current is 5 angle, you know that current is 5 angle 45 degree, right, and voltage is equal to say 70.7, that is your 71 angle 0 degree, right. So, you can easily your what you call, you can easily find out what will be your what will be your this thing power, right. So, that is why your what you call that Vi, it is cos theta. So, V is equal to your 71, right, this is RMS value, I is equal to 5 and cos theta cos 45 degree, that is 1 upon root 2. This 71 by root 2 approximately 50, that is your 250 watt, right. This is the power Vi cos theta. Earlier I showed you this I square R also 250 watt, so it has to be same, right. So that means all calculations are correct. If something goes wrong, if it is not matching, means somewhere your calculation is wrong, right. So we have to be careful about the calculation, because complex number is involved in every step. So this is how that your phasor diagram. So you have understood everything, that how we draw the phasor diagram, and I told you that your angle, and if you make it your what you call first, this is your first quadrant, this is your second quadrant, if you say this is your third and this is fourth quadrant, right. So voltage, this voltage is in the second quadrant, and this voltage Vc is in that your what you call your in that fourth quadrant, and this one is first. So it can be anywhere, because phasor is a rotating vector, right, where Z impedance is not a phasor quantity, it is a complex quantity, right. So that I told you. So this one example will help you a lot to understand each and everything, right. So all this write up is here, so you will read this. Now volt ampere active and reactive power, right. So volt ampere means Va, active and reactive power. So now this is your this thing. Now product of RMS values of current and applied voltage is called apparent power. That means your V into I is called apparent power, right. This is voltage, this is current. So volt is V, current is I ampere. So we call it is volt ampere, right, or you call volt ampere, right, or in short we call Va. A larger unit will be kilovolt ampere, kVA, or a megavolt ampere, and that this is also called apparent power. So apparent power is equal to V into I, right. So no cos theta is involved, it is V into I, right. So now active power, we have seen now that Vi cos theta, it is what? So active power, that is your Vi cos theta, this is Vi cos theta, that means cos theta is equal to P upon Vi, right. So that means P is the active power divided by the volt ampere, this is your what you call cos theta, and reactive power is equal to Q is equal to Vi sin theta, we call volt ampere, we call VAR, VAR, V for volt, a capital A small r stand for actually your ampere, but we call in short VAR, just to differentiate both, right. So Q is equal to Vi sin theta, we call VAR, right, reactive power. So let me clear it. So now reactive power, then sin theta is equal to then your Q upon Vi, right. So reactive volt ampere by volt ampere, that is Q upon Vi, right. So therefore if the current is, if your current is I, if the current is I, suppose this current is leading, this angle is theta, right, then your projection on this x axis is I cos theta, and this is I sin theta, and this is your voltage V, right. Therefore I cos theta, active or power component of the current, because power we know Vi cos theta, right. So this I cos theta, actually that is why we call active or power component of the current, right. So similarly this reactive power Vi sin theta, so this is actually reactive or worthless component of the your reactive power. So Vi sin theta, this is sin theta. So this is your reactive or worthless component of the current, right. Therefore this one, that means this triangle is there, it is I cos theta, I sin theta. For all these things, for all this arm you multiply by V. So this will be Vi, this will be Vi cos theta, this will be Vi sin theta, if you multiply by V. So just see, this diagram is like this. Next is your, if you multiply by V, it will be Vi, it will be Vi cos theta, it will be Vi sin theta. That means reactive volt ampere is equal to, this is your reactive volt ampere, reactive power, this is we call real power, right, this we call real power or power. Therefore volt ampere is equal to Vi, volt is equal to real power square plus reactive power square, right. So this is, I mean, if your real power is P, suppose if it is P we have taken, if it is Q, then this one will be P square plus Q square, right. So this is your volt ampere Vi. So let me clear it. So, calculation of power using complex notation. Now onwards, so everywhere we are using arrow and arrow. Now we will not do. We hope it is everything will be understandable. So, phasor and other thing, magnitude, everything I will tell. So, we will not consider, we will not your what you call again and again we will not put arrow and other thing, but understandable. So, calculation of power using complex notation, right. So, if you look into this phasor diagram, say this is my V, this is my V, and this is my reference line, this is my reference line, and this angle is alpha, say. So, this side your what you call this is this your horizontal projection V is equal to V cos alpha, right, and is vertical projection this one V dash is equal to V sin alpha. Similarly, this is the current, is horizontal projection, the your what you call I is equal to written at the bottom. Just hold on. So, it is your what you call this I, this horizontal projection I is equal to your I cos beta, and vertical one is I dash is equal to I sin beta, right, and angle between voltage and current, this is the angle between voltage and current is equal to alpha minus beta, right. So, that means this is actually the angle between the voltage and current is called the power factor angle. That means, for this kind of thing power factor will be cos alpha minus beta, right. So, because the your what you call, whenever you call power factor angle means is the angle between the voltage and the current, right. So, that is why it is alpha minus, difference is alpha minus beta. So, power factor angle is cos alpha minus beta, right. Let me clear it. Now, this voltage we can write, just let me move little bit up, right. So, this voltage you can, I am writing it later, I will show you. This voltage you can write, it is V angle alpha, right. That means V cos alpha plus J V sin alpha, right. So, V is the RMS value, everything is RMS now. So, that means V cos alpha plus J V sin alpha, right. This is V. Similarly, let me clear it. Similarly, for current it is I angle beta, that is I cos beta plus J sin beta, that is your I cos beta plus J I sin beta, right. This is your I angle beta. So, next is, that means, let me clear it, that means all these things V is equal to V is equal to capital V cos alpha, V dash is equal to capital V sin alpha, I is equal to your capital I cos beta, I dash is equal to capital I sin beta. So, all this expression whatever I have written here, V cos alpha you put V small v, and J your sin alpha, your V sin alpha you put V dash, you multiply, and V sin alpha is equal to V dash. Similarly, current I told you it is I cos beta plus J I sin beta. So, I cos beta is equal to I from that phasor diagram, and J I dash plus J I dash. When you read this video lecture, first you draw the phasor diagram on the notebook, after that look into that one by one, it is very easy, right. And the phase difference between voltage and current I told you alpha minus beta, hence the power factor is your cos alpha minus beta, right. Now, therefore, power factor is equal to, I told you, cos alpha minus beta. Therefore, active power will be V I cos alpha minus beta, right. So, that means active power P is equal to V I cos A minus B. So, cos alpha cos beta plus sin alpha sin beta, right. So, V cos alpha, this one if you multiply by V I, so V cos alpha is equal to put small v, and I cos beta you put V I, right. And because your I cos beta you put I, because we have taken the vertical and horizontal projection, that phasor diagram everything is written. Similarly, V sin alpha is equal to your V dash, and I sin beta is equal to I dash. That means, P is equal to V into I plus V dash into I dash. Here it is, all these things are given, V dash I dash, in terms of that we put that one, right. So, P is equal to V I plus V dash I dash. So, this is our real power, right, active power. Now, reactive power will be Q is equal to V I sin alpha minus beta. So, it is V I sin A cos B minus cos A sin B formula. So, sin alpha cos beta minus cos alpha sin beta. So, V sin alpha is equal to V dash, and your I cos beta is equal to I. So, it is V dash I minus V cos alpha is equal to V minus I sin beta is equal to I dash. So, Q is equal to V dash I minus V I dash, right. Now, current is equal to I angle beta, that means current conjugate will be I angle minus beta from your complex number, right, that is that I beta is equal to I e to the power j beta, right. That means, if we take its conjugate, then basically it will be I e to the power minus j beta. We are taking the conjugate, that is why this angle conjugate is minus beta. So, P plus jq is equal to voltage into your what you call your current conjugate. Now, to get this, why the conjugate, right, this we will find in book and other thing, but why is the conjugate we take? Actually, we take the conjugate, this one your what you call P plus jq is equal to voltage into current conjugate, or you can write P minus jq is equal to voltage conjugate just opposite into your simply current, right. Either way you can use, right, either P plus jq is voltage into current conjugate or P minus jq is equal to voltage conjugate into current, you will get the same result. Now, question is why the conjugate? Conjugate is actually to capture the power factor angle between the voltage and current, that is why we take conjugate. For example, before proceeding further, for example, suppose you have been given say voltage is equal to 10 volt is RMS, say it is 30 degree, right, and I is given, say I is equal to given, this is volt, and I is given say 5 angle minus 15 degree ampere, right. Now, question is then what is the angle between the voltage and current? So, in that case, suppose if I take a reference line, this is my reference line. So, V is equal to 10 angle 30 degree. So, with respect to this reference, it will be your this side, this is my 10 volt and this is my 30 degree, and with respect to reference it is minus 15 degree current. So, it will be on the negative side, this is my current I is equal to 5 ampere and this is my voltage, and this angle is 15 degree. Then question is, this is the voltage, this is the current. So, what is the angle between the voltage and current? It is actually 30 plus 15, that is your 45 degree, right. Therefore, then how we got the current if we do not take the conjugate, right. So, in general if you put like this, suppose we have taken P plus jq is equal to voltage into current conjugate. So, if it is I is equal to 5 angle minus 15 degree, then I conjugate will be equal to 5 angle 15 degree. It is your, because it is minus 15 degree. So, its conjugate will be plus 15 degree. So, voltage is 10 30 degree. So, it is 10 angle 30 degree into 5 angle your 15 degree, because current conjugate. So, that is actually 50 angle 45 degree, right. That means, this one will be your 50 cos 45. So, 50 by root 2 plus j your 50 by root 2, because sin 45 is also 1 by root 2. That means, my P will become, in this case for this example whatever I take, it will be 50 by root 2 watt and Q will be 50 by root 2 var, right, because P plus jq is equal to 50 by root 2 plus j 50 by root 2. So, real and imaginary part you separate. Now, you have studied in your complex number. So, that is why this conjugate is must, right. Otherwise, you cannot capture the angle between the voltage and current. Otherwise, if you add this, you are getting 45 degree, but mathematically how you will get it? Unless and until we take the conjugate. That is why, let me clear it. That is why we conjugate, we or what you call, we consider conjugate, right, to capture the power factor angle. That is why P plus jq is equal to voltage into current conjugate. I hope you are understanding now clear, right. So, just 1 minute. So, this is your P plus jq. Now, that means we calculate your what you call P plus jq is equal to, now voltage is equal to, you have this is horizontal component plus vertical component, V plus jv dash into I plus j I dash. Look at the phasor diagram, because you have two components, one is real component and another is your what you call complex this thing, one is horizontal, one is vertical. So, this can be written as V can be written as V plus j V dash. Similarly, I can be written as I plus j I dash and its conjugate, that means V plus j V dash into I minus j I dash, right. You multiply, if you multiply and simplify, you will find P plus jq is equal to this one, and your what you call, and this imaginary part is this one, complex part is this one. That means if you separate real and imaginary part, so P will become Vi plus V dash I dash, and Q will be V dash I minus Vi dash, right. So here we got to V dash I minus Vi dash using the relationship, and P we got Vi plus V dash I. So similarly, if you do this conjugate, you same result you will get, right. So conjugate is required to capture the power factor angle, right. I hope up to this single phase circuit, I hope you have understood this. Look, that actually AC circuit, it your what you call it involves complex number. So only 3-4 more examples I can show you, because but take any book, any good book I suggest you take and solve some problems, right. Because complex number involves your involvement means you need lot of computation time, right. So anyway, so these are the thing your what you call, as it is a basic course. So if you have any doubt, anything, you put the question in the forum, right. We will try to answer all these questions. Now next is you take a simple thing. Suppose it is given that V is equal to your what you call 100 plus J2 volt, and current is given 10 plus J5 ampere, everything you take in RMS, right. So VIP plus JQ is equal to, just for your understanding we have taken VI conjugate. So it is 100 plus J2 and I is equal to 10 plus J5, and it will be 10 minus J5, the conjugate, right. Therefore if you multiply, it will become 2000 plus J1500, right. So that means separate real and imaginary part. So P is equal to 2000 watt, that is 2 kilowatt, divided by 1000, and just let me move little bit up, and Q is equal to 1500 var is equal to 1.5 kilowatt divided by 1000, separate real and imaginary part, right. Now single phase circuit analysis. Suppose you have a circuit like this, right. You have a circuit like this. Say it is inductive circuit. This part is inductive, R1 plus Jx1. This is capacitive, R2 minus Jx2, and another thing is there, R3. Voltage across this, it is V1, it is V2, it is V3, and total is V, right. Supply voltage is V, and current flowing through this is I. Current flowing through this is your I. This is the I, right. Everything is RMS. This is RMS. Now everything where, unless and until it is stated in sin omega t, all are RMS, right. So this is your inductive part, this is capacitive part, and this is your, right, and this is just let me move little bit up. So when you solve this one, first you draw the circuit, then you look what has been done. So Z1 we are taking R1 plus Jx1, Z2 we are taking R2 minus Jx2, and Z3 is equal to say R3. So this is Z1, this is Z2, this is your Z3, this is your Z1, this is your Z2, and this is your say Z3, right. Although it is R, but we will write, but everywhere we will not put bar now, we will put simply Z and I and V, understandable. These all are phasor, your what you call I and V are phasor quantity, and this is complex quantity, right. So V1 across the voltage is I1 into your I into Z1, V2 your I2 into Z2, and V3 is equal to I into Z3. So here V2 is equal to I into Z2, and V3 is equal to I into Z3. So V is equal to, not putting arrow again and again, phasor quantity, understandable. It is not like a DC algebraic sum, don't do it. So it is a phasor sum, like vector sum, you have to do it. So V1 plus V2 plus V3 is equal to I into Z1 plus Z2 plus Z3 is equal to, you substitute all these values, V1, V2, V3, Z1 is equal to R1 plus Jx1, Z2 is equal to your R2 minus Jx2, and Z3 is equal to R3. You will get I into R1 plus R2 plus R3 plus J into X1 minus X2, or in general V is equal to I into Z is equal to I into R plus Jx. So R is equal to, like your series resistance adding, same as DC circuit, R will be R1 plus R2 plus R3, and X will be X1 minus X2, because one is inductive, another is capacitive. So X1 minus X2, right, and V is equal to I into Z, that is I into R plus Jx, and R and X are defined here, right. Therefore Z is equal to, now you know, root over your R square plus X square, the magnitude, because it is your R plus Jx, so its magnitude is root over R square plus X square and angle theta, right. Therefore theta is equal to your tan inverse X upon R. So, that is x is equal to x1 minus x2. So, tan inverse x1 minus x2 upon r1 plus r2 plus r3. Therefore, I is equal to V angle 0 by root over r square plus x square angle theta, right. So, this is the equivalent total impedance is equal to V angle 0 minus theta divided by root over r square plus x square. Therefore, it is V upon root over r square plus x square angle minus theta. This is I, and power factor is cos theta, right. This is the angle between the voltage and current, because voltage angle is 0 and current angle is minus theta. That means current is, say, if it is theta is positive, then current is lagging. If theta is negative, then current is leading, right. So, tan theta is equal to x by r. This one you can write sin theta upon x is equal to cos theta upon r is equal to 1 upon root over r square plus x square, right, because it is sin theta by cos theta is equal to x by r. Therefore, sin theta upon x is equal to cos theta upon r is equal to 1 upon root over r square plus x square. So, this is your cos theta, r upon root over x square plus x square, right. So, with this one we will take one small example. Suppose it is 4j3 and this is 6 minus j8 and 2 V1, V2, V3 and voltage is 100 volt is given, right, and this is V1, V2, V3. So, I is equal to V by Z. So, V is equal to, if it is V is 100 volt is given, means V is equal to 100 volts given, means you will always take this one, that it is 100 angle 0 degree, that one reference you have to assume. So, it is RMS value, all are RMS value. So, 100 angle 0, and this is the current is flowing, right. So, 100 angle 0 degree. So, let me clear it. So, just hold on. So, this one your I is equal to V by Z, 100 angle 0 by Z1 plus Z2 plus Z3. Simply you solve it, you will get 7.69 angle 22.6 degree ampere. Simply you solve it. Similarly, then V1 will be I into Z1. So, just I you know the I, you multiply by Z1 4 plus J3, you will get 38.47 angle 59.5 degree. Similarly, V2 is equal to I to Z2, this is I, Z2 is 6 minus J2, multiply and simplify, you will get 76.92 angle minus 30.5 degree. Similarly, V3 is equal to your I, your what you call into your Z3 is R only. So, if you multiply, this will be R is your what you call R is equal to 2 ohm. So, it will be 15.38 angle 22.6 degree volt, right. For checking, if you add, if you add V1, V2, V3, it will become 100 plus J volt. I mean, if you look into the circuit, polarity will be anyway this one, plus minus, you mark the polarity, many places, intentionally I have not marked it here, just to show you in the, your what you call in this lecture class, right, plus minus. So, it is moving like this, right. So, everywhere you can, if you move like this and mark the polarity plus minus, right. So, this is your, suppose this is one part, this is your capacitive part and this is plus this one. So, you can make it plus minus, right, plus minus and plus minus if you make it and apply your KVL. So, it will be V1 plus V2 plus V3 is equal to V, but remember this is your phasor sum, do not add the magnitude one, never you will get the result, it is phasor sum, right. So, all this angle you have to, voltage and angle you have to consider, right. So, that means that is why if you check it, then you will get this one is equal to your 100 volt, right, for checking. So, everywhere not putting arrow, but it is a phasor sum, you add it, and P1 is equal to I1 square R1, you will get 237 watt, P2 is equal to I square R2, right, R2, that is your R2 is 6, R1 is 4, so it is 355 watt, and P3 is equal to I square R3, it is 118 watt. Total power, if you add P1 plus P2 plus P3, it will become 710 watt. And if you use V is equal to 100 angle 0, I is equal to 7.69, power factor angle is 22.6 degree. So, cos 22.6 degree is 0.9232, it is leading because angle is positive, current angle is positive, right, because voltage is angle 0. So, P is equal to Vi cos theta if you make, you will get same as 710 watt, right. So, here also 710 watt, you will get the same result, either way you can do it, right. And this R1, R2, R3 is this one from the circuit, this is your, this is R1 is 4 ohm, R2 is 6 ohm, R3 is equal to 2 ohm, right. So, with this we calculated this power calculated. Similarly, using Vi cos theta we got it, and your job is you please draw the phasor diagram. Phasor diagram I have not drawn for you. So, please draw the showing V1, showing V, I, V1, V2 and V3 everything, right. So, draw the phasor diagram. Thank you very much. We will be back again.